Hello, my name is Dr. Colin Summerall, and I'm the invertebrate paleontologist in the Department of Earth and Planetary Sciences at the University of Tennessee. Today we're going to be discussing Universal Elemental Homology, a series of homologies for stemmed echinoderms that allow us to discover corresponding parts in very distantly related groups of echinoderms. One of the fundamental problems we have in echinoderm morphology is that the lexicon of terms used in different groups of echinoderms developed over 2 centuries by different workers working on different groups in different countries with different languages. As a result, terms like oral plate may have very different meanings in different groups of organisms in terms of homology, whereas other things like oral plates, as we'll be discussing in a moment, may have multiple different names depending on the group of organisms you're working on. This causes nothing but chaos. Universal Elemental Homology rectifies this by coming up with a common lexicon of terms used across stemmed echinoderms. The oral plates are probably the easiest group of plates to identify within a stemmed echinoderm. Generally speaking, the summit of the animal, the top, is roughly oval in shape. There's a centrally located mouth from which all of the rays radiate like this. And the sutures between the oral plates lie upon those rays themselves. Typically, the CD side is divided into 3, with this being the A, B, C, D, and E ambulacra. And then we simply label the plates in an organized manner. And the convention is this is oral 1, oral 2, oral 3, oral 4, oral 5, oral 6, and oral 7. Note that the CD side typically has 3 plates, and those 3 plates are intimately associated with the hydropore and the gonopore. The ambulacra, in turn, are covered by a series of cover plates. Those cover plates are divided into 2 fundamentally different types. There are a few cover plates that sit in key positions here, 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 and here. And these are the primary peristomial cover plates. These are the first plates that form embryologically and can be traced throughout the ontogeny of the organism. Later on, additional plates are added along the ambulacral grooves like this, covering the ambulacral system. And these are simply called cover plates. And they are found in all groups of stemmed echinoderms. So when presented with a real specimen like this parablastoid Eureka-blastus, how do we approach it? Well, the first thing we would do is look for the oral plates. The oral plates should be interradially positioned and proximal so that they form the frame of the mouth. So there they are in red, oral plates. Then we try to find the plates that cover the orifice of the peristome itself, the primary peristomal cover plates. There they are in blue. Then we try to find the flooring plate systems which form the distal food grooves. There they are in green. And then finally the cover plate system covering the entire ambulacral system. There in brown. So that gives us a full-blown model for Eureka-blastus. So to show this whole model again in a line drawing, we have the interradially positioned oral plates here in red, marking the boundaries between the 5 main ambulacra. Those 5 main ambulacra are then covered with cover plates, including the primary peristomal cover plates that sit interradially in those primary positions. Those are the first cover plates to form. And then the food grooves distally are formed from these floor plates in green that in this case have brachial facets to support accessory feeding appendages. Finally, the entire system is covered by the distal cover plate system, here illustrated in brown. To show you the power of universal elemental homology, I'd like to show you Bystomia cystis. The original description defined edge plates here in pink and peristomal plates here in blue on an otherwise weird curved ambulacral system with two separated mouths. If we look at this through universal elemental homology, though, it actually makes much more sense. Here's our three posterior oral plates, O1, O6, O7 with the hydropore and gonopore. O2 and O5 are positioned here. And then these in green are the floor plates coming off. There's actually nothing weird about this other than the peculiar nature of these plates. Their number and their position is unchanged from the original model. And even in a fairly normal-looking echinoderm with unusual morphologies, like, for example, only having 4 ambulacra, such as this Apiocystides, universal elemental homology holds very well. So here, we see the oral plates in red. There's 3 here, O1, O6, O7. Here's 2 and 5, and O3 and 4. An ambulacrum should come off of that suture between 3 and 4. But it doesn't because this group of rhombiferans all lose the ambulacrum. Floor plates coming off here in green have our brachial facets, and then the cover plate system is simply covering those ambulacral food groups. Universal elemental homology has also helped make sense of the tegments of crinoids. It used to be thought that tegments of the crinoid, like this Marsupiocystis, are simply just a random array of plates. But if we look for the homology, we can actually see it quite well in this area. We zoom in, and our primary peristomal cover plates are still sitting there in the 2-on-2 arrangement that we'd already seen, and the cover plates of the ambulacral food groups are still arranged in a more or less biserial manner. Even something as crazy as this still retains that universal elemental homology character. The 5 primary peristomal cover plates here, and then the distal cover plates coming off of that in a biserial manner. And finally, I think it's important to note what universal elemental homology is telling us about the deltoid plates of blastoids. Deltoids are typically thought of as a body plate. You can see them here in red. But notice that I've also colored the plates around the mouth red, like their oral plates. In thin section, this actually becomes quite evident. This is a thin section through the top of a Pentramites. This is the deltoid plate sitting here. Those are the floor plates called side plates in blastoids, and that's the lancet plate, side plates in another deltoid. Notice the deltoid plate is an optical continuity all the way to the edge of the mouth. That is the oral plate. And note that the lancet plate here doesn't actually reach the mouth frame. So we can place blastoids into the universal elemental homology like this. These are the ambulacra, A, B, C, D, E, and these are our different deltoid plates. And notice again, it's a compound plate in the CD interarray. Because universal elemental homology allows us to precisely identify individual skeletal elements across echinoderm taxa, it becomes an indispensable tool for helping to construct phylogenetic characters so that we can understand the echinoderm tree of life. Thanks for watching, and we'll see you next time.